answer to each, but I will have covered all of these in the webinar today. So rest assured, we're going to cover all this information. All right, so some foundations. What is noise? So noise is actually unwanted sound. It can either be an irritating type of sound or it can be disabling and harmful to your hearing. And really, we're going to focus on the disabling type of noise, and that is noise with sufficient sound energy to cause damage to the cochlea in your ear, such that you end up either with tinnitus or noise-induced hearing loss. And so I think it's recognition of the different types of noise this important first step. You can have a very a very irritating type of noise that may not have the energy to cause noise-induced hearing loss. And so although it may be irritating and there might be other reasons why you want to correct that situation, it doesn't create a risk to your hearing. And so we're going to make those distinctions. So noise is actually a variation in sound pressure. And so your ear is actually a very specifically tuned differential sound pressure measuring device. And it's through your growth that you've calibrated your brain to understand these fluctuations in pressure, and you hear them as sounds of different frequency, different pitch, as well as different loudness. It's quite a remarkable device, actually. The capacity for someone to be able to hear real subtleties in sound. Like you think of a musician, for example, or even in my house, I can tell when someone comes in the front door, I can tell based on the way they walk. I can hear the subtleties and the difference between they walk, whether it's my wife or either of my two kids. And so the ear is a remarkably well calibrated sound pressure device that gives us lots of very useful information. And so when you think about noise, one of the challenges we have as technicians is the noise scale is measured in decibels on the A scale, dBA. But the dBA scale is a logarithmic scale. And this is one of the biggest challenges in communicating risk, is in communicating this logarithmic scale. And so on a logarithmic scale, if you see, background noise levels in traffic might be around 80 decibels on the A scale. When you move from 80 decibels to 90 decibels, see, that looks like a relatively small increase, but it actually represents a 10 times noise dose exposure. So a movement of 10 on the dBA scale is 10 times louder. So if traffic's 80 decibels on a quiet back street, 90 decibels is 10 times louder than that. 100 decibels is 100 times louder than that. 110 decibels is 1,000 times louder than that. And so this is a confusing point for lots of people, that very small changes in dBA level represent very significant changes in noise energy or noise dose exposure. And so one of the changes to the legislation is that the threshold at which we now have to do assessment has changed significantly. Basically, the government has reduced the level in half as the threshold level for when we have to do assessment. And I'm going to talk more about that later on. So this is the confusing thing for people, because they think when it goes from 70 to 90, it's only a small percentage increase, when in fact a movement of decibels from 70 to 90 is 100 times more sound energy or 100 times dosing. And so small noise level changes in decibels is actually huge changes in noise dose to your ear. And so here's how your ear works. So you have the outer part of the ear, we call that the pinna, and the pinna is designed to defocus the sound waves incident on us, and they focus them into the ear canal, and the sound waves then hit the eardrum, and the eardrum converts sound pressure fluctuations into mechanical energy. So the eardrum starts to move back and forth, and it moves the three bones of the middle ear. And the three bones, the third bone of the middle ear taps on what's called the oval window of the cochlea. So this spiral thing here is the cochlea, and it taps on the window of the cochlea, which causes vibrations in a gel-like substance that's in the cochlea. And those vibrations move down the gel. And inside the cochlea are hairs. And as the hairs move or bend, with the vibration. Each hair is attached to the auditory nerve and sends a signal to your brain, and your brain recognizes it as a sound. And so it's quite a remarkable little bit of device. And we're going to talk about how high noise levels harm it and how we can best protect people from noise-induced hearing loss. And so it's still quite remarkable that in today's day and age that we have people that lose their hearing. One of the questions people asked is why this change all of a sudden? And the reality is because in today's day and age, we continue to have significant hearing loss in our working population. And if we were doing a good job of noise and hearing conservation, we wouldn't see this ongoing hearing loss. Noise exposure and the loss associated with it is a long-term health risk. It's a chronic condition. If you lose your hearing because of noise exposure, it's because you have had cumulative exposure over many, many years. And so we have this condition that, or this situation where in Alberta, we continue to have high noise-induced hearing loss. And so we're paying out WCB claims, and it's not just the cost side of it. It's sort of a tragedy that people late in their lives, maybe at a time that they're just about to retire, have actually lost significant hearing. And so there's a lot of reasons why it happens. It happens really slowly, and there's no pain, and people don't see overexposure. If I use a chainsaw without hearing protection, at the end of the day or end of the hour, I don't really feel anything. But if I continue to do it, I'll eventually lose my hearing or suffer tinnitus, like a type of ringing in the ears. So there's a lot of reasons why it is not really taken seriously, is the way I would say it. When we go into the workplace, I can tell you we see it repeatedly that workers are not wearing their hearing protection properly. And either nobody knows that is the case, or there really just isn't enforcement of the proper use of hearing protective devices as a significant control. So we continue to see noise or hearing loss in our population. And so part of the reason the government is making this new push to force employers to assess noise levels in the workplace, even when the noise levels are quite low, and forcing employers to do a better job in terms of educating and enforcement of the use of hearing protection is part of that result. And so one of the issues that we have is from a WCB point of view, the Workers' Compensation Board pay out claims. And one of the reasons why hearing loss claims are not as well noted by big companies is because it's a pooled risk. Like if one of your employees gets hurt and they go off on WCB, that impacts your company's experience, your this year's costs. And if your experience rating is high compared to your employers in your same pool, your WCB rates go up. And so people notice it. Your rates go up, and the bean counters or the accountants or your senior leadership start to say, like, hey, why are we paying more WCB claims? We better get our system working. But for noise, they don't attribute the noise loss costs to your account. It is a pooled cost because it's too difficult to track exactly where the overexposure happened. So the cost of a hearing loss claim for WCB is just pooled, and all employers pay it. And so employers don't see the cost directly on their experience or their claims rating. And so in some respects, it's not seen as something that's as important to control. But WCB are reporting that we continue to see noise hearing loss in employers, and they're continuing to pay out more and more claims. And part of the changes we're seeing today is the government's response saying, I think we can do better. And so what's happening is, this is another noise level chart. What's happening is right in this middle section here between 80 and 85 decibels, that's where noise-induced hearing loss is attributed. And anything above 85, we associate with an increased risk of noise-induced hearing loss. And so really nowadays, even an air conditioner in a window-mounted air conditioner, if you're sitting relatively close to it, it can produce 80, 82, 83 decibels. And so it's starting to produce the type of noise level that the government is concerned about and wanting to further regulate. Some of the other health effects associated with noise exposure. High noise exposure causes a lot of things. It causes a bit of stress. If you ever go into a high noise area, you'll kind of notice your shoulders tighten and your eyes may squint. And this is a normal response to overexposure to noise. It's also associated with increase in heart rate and blood pressure. It can affect your sleep patterns and it can affect your digestive processes. And in general, aside from the temporary or permanent hearing loss, exposure to noise can cause quite a lot of stress, which can result in cardiovascular health risk, in fact. And so it's not just your hearing. Noise exposure control is necessary to allow for the total worker health kind of concept to be true. So there's three types of hearing loss, and the one we're most interested in is sensory neural. The first is acoustic trauma. If you're exposed to like a mortar or an explosion, a mortar fire and explosion, it can cause damage to the eardrum or disconnect the bones of the middle ear, and we call that acoustic trauma. A conductive hearing loss is a blockage in the flow of sound to the cochlea. It can be caused by wax buildup or also a stiffening of the bones of the middle ear or a stiffening of the eardrum. Acoustic trauma and conductive hearing loss can largely, in many cases, be treated or corrected. But sensory neural hearing loss is noise-induced hearing loss, and that's from chronic overexposure to noise. And what happens here is the overexposure and noise impacts the cochlea. The cochlea is the nerve attachment to the brain. It's the final piece of hardware that converts these sound pressures that are incident on the pinna and convert it into an electric impulse to the brain. And actually what happens is from overexposure, the hairs in the cochlea, the hairs that are so important to be able to sense the pressure and send a signal, the hairs become damaged. And this is an example of cochlea. This is actually a chinchilla's cochlea. It's not a human cochlea. A cochlea is like a spiral or seashell shaped device. And so at the lower center here is where the oval window would be, and the bones tap on it, causing vibrations to go down the cochlea. And as those vibrations stimulate those hairs, the hairs are attached to nerve endings, which go to the brain. And when those hairs are vibrated, the nerve impulse goes to the brain and it's recognized as a sound. As you can see in this cochlea over here on the right, the hairs have been damaged, flattened, or destroyed in this section of the cochlea. And as a result of overexposure to noise, the hairs are now flattened. And since they're not there, if a sound does come in at that particular frequency, there's no response by the brain. The brain doesn't get a signal. And so you are in fact deaf to noise in that frequency range. And a big challenge is that where noise-induced hearing loss happens is right at the 4,000 hertz notch associated with regular speech. And so when we lose hearing, we lose our ability to communicate. And so this is the government's, this is part 16 of the code as it will be. There's only a few changes, but I just wanted to go over it. I mean, our first duty is to reduce noise. Our first duty is to build any new systems so that we're not noise exposed. The challenge is it's really hard to build a workplace in an industrial setting and make sure there's no noise. So although that's the duty, we have to use other controls following the hierarchy. And what the legislation says is that you have to keep exposures below 85 decibels, okay? So 85 dBA becomes the threshold limit or the occupational exposure limit for noise exposure. In fact, there's a table in the legislation, Schedule 3, Table 1, that lists the allowable exposures and how long it takes to get fully dosed. So at 85 decibels, you can see you can be exposed for 8 hours or less and remain below the total noise dose for the work shift. If the exposures are higher, say 88 decibels, you become fully noise dosed in 4 hours. So anything more than 4 hours, and you're creating risk of noise-induced hearing loss. And so you'll see at really high noise levels, like at 112 decibels, you become fully dosed in under a minute. And so this is my example of using a chainsaw for like just an hour a day without hearing protection. Although you may not realize it, you can get overdosed day after day from a relatively short activity at high noise levels. And so this is why we continue to see noise-induced hearing loss, because people don't feel it, don't feel the loss, and it's a very subtle loss that happens over a long period of time. So this is one of the big changes in the code right here. It says that if workers are or may be exposed to noise at a work site or work area in excess of 82 decibels, it used to say 83. Sorry, it used to say 85, and 85 decibels is twice as much noise as 82. So in effect, they're forcing employers to do noise assessments in much lower noise areas. So if you've done a lot of noise measurement in your workplace, the code really requires you go back and check and find these lower noise areas that were previously excluded from your noise and hearing conservation program. And so all of the low noise areas of your workplace now are potentially considered to be areas that require noise and hearing conservation and control. And so this is one of the major changes that's going to drive action. People are going to have to go back to their workplace, and they'll probably have to update their noise maps, and they'll have to identify the areas that have workers working in them where they're exposed to 82 or more, and undertake dosimetry to assess who needs proper noise and hearing conservation program or participation in the program. And so what's happened, if we think back to this little chart I showed you, we used to use 85 as our cutoff, but now all of a sudden we need to look carefully in this area between 80 and 85. And so like even a vacuum cleaner can produce 80 decibels of noise. And so what we're talking about is relatively low noise levels that now require that we undertake an assessment and make decisions around which workers are at risk of overexposure and which workers need to be participating in the noise and hearing conservation program. So this 82 decibels is one major change. And how do we actually make these noise measurements? That's a question that came up. How do we do this work? I was going to talk a little bit about it. They're saying what's required, and this isn't new. They're saying that the assessment should be conducted in accordance with CSA standard. So the question is, how do I assess noise? We follow the CSA standard. And I'm going to talk briefly on what the CSA standard says. It basically says that we should do some instantaneous noise measurements to get a general feel for noise levels. Then we should do some noise mapping if the noise is continuous. And if the noise isn't continuous, or for employees that are exposed to high noise, we have to do some dosimetry. So we're measuring their integrated noise dose. And even with that, all the work is actually just done in accordance with CSA. Okay, and so the question is where do we have to assess? And where we think that the levels are 82 or higher, how do we assess? We follow the CSA standard. And then the other piece is, for the purposes of doing the assessment, we need to use a type 2 instrument. And there's nothing new about type 2 instruments. All of our noise assessment equipment is type 2. They make the distinction because a lot of smartphones nowadays have a sound level meter built into them. But cell phones, smartphones are only a type 1 device. And the difference between type 1 and type 2 is a type 2 device has been protected from electronic interference. And so that you know that when it's reading out, there is no electronic or electric or magnetic field interferences in how it's performing. Whereas if you were to use your cell phone to try to do your noise assessment, if there are strong electric or magnetic fields in the workplace, it could disrupt the way the phone is operating such that you won't get real readings. Anyway, so that's what the code says for how we measure. And so again, we follow the CSA standard, and then we use type 2 equipment. This happens to be Quest. There's many manufacturers, B&K, and lots of different manufacturers. This is in the upper right is a Quest sound level meter. It's a type of instantaneous direct reading instrument that you can turn it on and measure the noise levels. This other instrument with a little foam microphone cover is a dosimeter, the type of instrument a worker would wear for a full shift or a portion of a shift to measure the integrated noise dose over that period. And so that's really how we do the assessment. We follow the CSA standard and we use type 2 equipment and we measure noise in the workplace. And so really you follow this sort of 3-step process. Step 1 is just to do a scanning review with a sound level meter under normal operations. If you work in a mechanic shop where impact wrenches are starting and stopping, it's tough to get a true measurement just with a sound level meter, and you'll need to use dosimeters. But in most workplaces where you have a steady noise, you'll do some spot measurements to see if anything's above 82. And if it's above 82, then you'll do a noise map. And once you have your noise map, you'll be identify the areas where there is risk of exposure. You'll then look to see what workers are working in what areas and for what duration, and then you'll do dosimetry, where those workers wear a dose meter that can measure the integrated noise exposure. And then from there, you can determine who needs to be involved in the noise and hearing conservation program. And we'll talk more about that a bit further on. And so the code speaks to that. The code says that you'd have to do a noise exposure assessment and the person needs to be competent, which means, you know, what competency means, right? Having had sufficient education, training, and experience to be able to do the work they're being asked to do. And so it's how do you calibrate the equipment? How do you operate the equipment? The do's and the don'ts, and demonstrate an understanding of what you should be doing to assess and make measurement of noise levels in comparison to the code. And so I'm happy to talk more about that a little bit later on. And then it says that if you confirm workers are being overexposed, you need some procedures, you need to identify the work areas, you need to talk about how you measured it, you need to build out a program for educating and training workers, and what your noise control strategy is. Selection, use, and care of hearing protective devices. They want you to post warning signs. You'll now need audiometric testing, where you're testing workers' hearing, because that will confirm that your hearing conservation program is working. And then you need to fit test their hearing protective equipment. And then typically there's looking for an annual review of the whole program. And so I think I talked a little bit about this idea of that we need to wear hearing protective devices. And so people are familiar with that, whether it's muffs or plugs, semi-oral devices. There's a wide range of hearing protective equipment. But the key thing is that the stuff you're wearing is CSA standard rated, and that the equipment is being fit tested. And this is a new change in terms of what's required. That equipment for CSA has to be fit tested in place. And so I'll talk about the different types. So you're probably pretty familiar with the range of equipment that's available. Muffs and plugs and semi-oral devices, and there's A-rated equipment, which provides the greatest attenuation, and most muffs are B-rated, and some semi-oral devices, this type of thing you wear around the back of your neck, is a C-rated device. And so once you know your noise levels and once you know your workers' exposure risk, you can design your noise control program, including selection of hearing protectors consistent with the numbers you've measured. And this is a table showing how you select your equipment. If the integrated noise dose is less than 90 decibels, an A, B, or C class of hearing protector will work. And so for the very low noise levels, any of those types of hearing protection will work. The new requirement, of course, is that hearing protection is fit tested. As you get into the higher and higher noise levels, you have to go to a class A device until eventually you're wearing plugs and muffs. And in the super high noise levels, even with plugs and muffs, you have to reduce time of exposure because workers can still be overexposed in those super high noise levels. And I'd be happy to talk more about that if people have questions under what circumstances that works. Yeah, so now we have to select our hearing protectors in accordance with CSA, but now there's the fit testing piece. And this is what's new. And this is, I think, what has caught a lot of people off guard. Many people are familiar with fit testing for respirators, whether it's quantitative or qualitative, like irritant smoke versus like a port account fit testing. Effectively, that's what CSA requires now, quantitative or qualitative. And that CSA standard describes the process. And I can talk a little bit about what they mean by fit testing. One of the key things is that regardless of whether you use quantitative or qualitative fit testing, we need to educate employees on how to properly use particularly plugs. And whenever I'm teaching this in class, even to safety people, I'll hand out plugs and say, okay, everybody, put your plugs in and let me show me how you do it. And I can tell you that a high percentage of people first are embarrassed. They think this is common sense and they know how to do it. And yet when left to their own devices, about 80% of people do not put the earplugs in properly. They do not get full attenuation. In order for you to get the designed attenuation, the plug needs to be spun between your fingers sufficiently that you can push it all the way into your ear past, there's a little cartilage notch on your ear. Not everybody has the cartilage notch, but typically there is one right about where my finger is. And the plug needs to get behind that for full attenuation. And so the reason that we have this change to the code is because we as a safety community or the operations team have not been getting employees to wear their hearing protection properly. And on an ongoing basis, our workforce as a whole is being overexposed to noise, such that workers' compensation is measuring the loss and the claims that they're paying out. And so these two major changes that have come in, the 82 decibel threshold requiring that you reassess, and the need for fit testing of hearing protective devices are two new initiatives to try to improve the use of hearing protection in the workplace such that hearing loss is better controlled. So there's two major systems available for quantitative fit testing. 3M has a system, and 3M's system only works for 3M hearing protective devices. So if you are a client and use 3M's earplugs, you can use the 3M EarFit system. And what this system allows you to do is you are fitted with a ported earplug, which is then properly put in place. So you can see on the lower right here, a worker has that plug properly inserted deep into his ear below that cartilage notch. And it's a ported plug. And so what they are doing is they are exposing the worker who is ported to noise. They're measuring the noise outside, and with that porting device, they're measuring the noise inside. And the difference between those two is the attenuation. And if that plug is properly inserted, you will measure an attenuation such that the difference is below 85 decibels, meaning that the amount of noise getting inside the ear is less than 85. And so that's how 3M system works. So if you're not a 3M hearing protective device user, it can't be used in your workplace. The other type of quantitative fit testing is VeriPro. And VeriPro uses a different system, but it is basically doing the same thing. It's a differential noise system. And we used that. EHS, we did quite a big project. You know, it's almost 10 years ago now, or just over 10 years ago. When VeriPro first came out with this, we did a big project doing quantitative fit testing of workers. And I think I have a slide I can share with you on what the results look like. But it's been around for a long time because the government didn't really enforce it, or it wasn't specifically mentioned in the legislation. There's a lot of reluctance to people to use it. What we found the greatest value in it is in teaching workers to insert their hearing protective devices properly. And by showing them how to do it and then testing them to show the attenuation, we're able to verify that they can get good fit. So it's very much like respiratory fit testing in that it's part of an education process for your employees, that we show them that with the respirator fitted in a certain way, we get the protection factor we want. The same is true with the VeraPro. And so as I mentioned, 10 years ago, we did a big study, and this was some data that came from it. We had 43 test subjects. And what you do in the VeraPro test is you just tell the worker, hey, just put your plugs in. And then we measure it, and we see how much attenuation they're getting. And then we show them how to put their plugs in properly, and we get them to do it properly. And then we're able to show them that the attenuation or the protection is much, much greater. And so this was with 43 test subjects, and this was on the first test. And so we found that, some people in this little test group, 13 were only getting 1 decibel attenuation. And lots of workers are needing 10 or more decibels attenuation. But some workers were getting good attenuation. There were 11 that got more than 10 decibel attenuation, and there were 9 that got more than, I think that says 18 decibel attenuation. And some workers knew how to put their hearing protection in properly. 10 of them put their hearing protection properly and got more than 20 decibel attenuation. And so does qualitative fit testing work? Absolutely it does. It is a tool that teaches workers how to put their hearing protection in, and then proves to them that if they put it in properly, they'll get the noise attenuation they need to be protected. And so really that's what's important, is that you teach workers. It's part of your hearing conservation program. The challenge with it, just like fit testing of respirators, is after they leave your test area, after they're finished their training and education, we do need a process to verify continued proper use of hearing protection in the field, because that's where the noise overexposure happens. But this at least gives us a point in time when we sat down with the worker and we talked to them about noise, and we talked about the risks, and we told them what the legislation says, and we showed them the equipment. We taught them to wear it properly, and we showed them with a test that when you wear it properly, you're getting the attenuation you're supposed to get. And so whenever you go out into the noisy work areas, make sure you put your plugs in the way we've just shown you and the way that you have just done it. And you'll get good attenuation, good protection, and it means when you go to retire, your hearing will be intact. And so it does work. It's a good system. So qualitative testing is part of the process too, and that's really verifying the quality of the work, quality of the application of the tool. And so it really means that you sit down with each worker, show them how to install or wear hearing protective devices, and show them what looks good and what looks poor, and have them do it repeatedly until they can demonstrate that they can get their hearing protective devices in properly. And I challenge you all to go to your workplace today if you're in the plant and go look around. And I think you'll find quite a few people wearing their hearing protectors the way this little graphic on the right is wearing them. And that is that a lot of the hearing protector is sticking out. And so if it's sticking out, it is not attenuating the noise. In order for it to work, you need the full length of the plug to be in the ear canal to give you that complete attenuation necessary for proper protection. And so you'll see a lot of these improper and poor installations of hearing protective devices. If someone is wearing their earplugs properly, when you look at them front on, you should not be able to see any earplug sticking out past that little cartilage notch. And I can tell you, if you go to the workplace, you'll find people not wearing them properly. And it's not malicious on their part. It's just, I would call it ignorance. They just didn't know. They've never really been shown. It's certainly not been enforced. And so it's really their loss in the end. Many years from now, they lose their hearing. And as they go into retirement, it's a kind of a tragedy of our system and our system letting them down. But we can do better. We just need to pay attention to it and put some energy to it. So audiometric testing is still required. There's really no changes to the audiometric testing rules. And so if you have been doing audiometric testing and if you have identified your at-risk group, you'll continue audiometric testing. The difference is some of the people that may have been outside of the group in the past under these new rules may be inside the group. So once you've completed your repeat testing and measurement of noise levels, your audiometric testing program can continue as it has been. And basically, it's any overexposed worker has to participate in testing of their hearing. And the idea is that if we test employees' hearing, and we verify that they've got no hearing loss today, and then we test them again in 1 or 2 years, and we continue to verify that there's no measurable hearing loss, it is proof that our system's working. If we start to see small amounts of hearing loss, we can intervene before it becomes debilitating. And audiometric testing just has a person sit in a sound booth and gets exposed to very small noise level, very small sound levels, and looks for the threshold of hearing across a range of frequencies. I think most people are familiar and have probably participated in this. And when you experience noise-induced hearing loss, you'll get a characteristic 4,000 hertz notch, which is quite different than presbycusis, which is nose-induced, or which is hearing loss just associated with old age. So it's very, very obvious when a worker's been overexposed to noise, because they get this notch, this loss of hearing right at that 4,000 hertz level. And the 4,000 hertz level is the level at which we talk to each other, most people, is conversational frequency range. So the audiometric test, there's requirements in terms of, how it's undertaken and who interprets it. And there's lots of audiometric testing companies available, and they will all be able to provide support to you and provide the testing required by the legislation. And usually part of audiometric testing, they'll do some other basic case history on other issues related that could impact. And so it becomes a medical test, and it's a medical record, and it's managed confidentially the way all other medical records would be managed. One of the things I did want to mention, though, in order for audiometric testing to be completed, it needs to be in a sound controlled environment. Typically, people have a booth. The booth might be in their office, or the booth could be truck or trailer mounted. But the background levels required for an audiometric test to be undertaken are specified here in Table 3 in the code. And that 22 decibels is a very low level. A typical office area, you could not achieve background levels this low. And so you couldn't just do an audiometric test in an office, even a quiet office. The toughest ones are the low frequency, 500 and 1,000 hertz. It's going to be, that's very quiet. So typically, or a requirement would be that audiometric tests be in a noise controlled booth. And then the booth itself has to sort of show that it can meet these background levels. So you can't just do audiometric testing in a quiet office. It's just not quiet enough for the test to be accurate. And so if you have high noise levels, if workers are at risk of exposure, the government has what they call a noise management program. And it's what I would call a noise and hearing conservation program. They call it noise management, but it's really everything you're going to do. How did we test? When did we test? How we educated our employees, what training we do. Do we do job observation? How do we reinforce good use of hearing protective devices? Who's being audiometric tested? How are we managing their data? It's all rolled up and wrapped up into a single program. And the big changes in the code are really just that the threshold for you being required to assess the risk of noise exposure is 82 decibels. And so that's a big change. And then the other piece is, if your workers are using hearing protective devices, plugs, there's a require that we fit test them, and that we have records of this fit testing. And so the noise management program, this is everything that was there before, and then the only real change in the code is the fit testing part, that we need to be fit testing workers. And the government believes that the same with respiratory fit testing. If we go to the point of sitting workers down one-to-one and show them how to wear hearing protective devices, don't assume they know, and reinforce the need for them to protect their own hearing because it's an asset of theirs, that they will do a better job with it. And I think it's true. It's the same with respirator fit testing. Once you show a worker how to wear a respirator properly, when they're using it to protect their own health, if they know how to do it properly, there's a much greater likelihood that they'll do it properly. So yeah, so you need a hearing conservation program. And so it really just includes all the things we talked about, that you monitor for noise, you know where the high noise levels are, you've built a control strategy. It may include hearing protection. You fit test your workers, you educate them, you train them, you do audiometric testing. You might do some job observation to make sure people are wearing their HPDs properly. You do, reinforcement of proper use and some re-education where workers may need it. And if it all works out well, years down the road, we have a workforce that have their hearing intact and they can retire and be able to continue to hear all the nice things we like to hear. So your employer's action plan, here's what you need to do from a code point of view, is get out all your old noise data if you have it. If you don't have it, then you're starting from scratch, but that's okay. Get out all your noise data and update it. And so basically step one is a area instantaneous noise measurement during all different types of conditions, normal and upset, during different jobs and tasks and operations. And your key is anything over 82 requires you look more carefully. If you measure 82 or more, my recommendation would be to do a noise map if noise is fairly consistent. If noise is inconsistent, like in a tire shop, noise mapping won't be very useful and you would move straight to a dosimetry. But anyway, after doing a noise map, then you'll identify workers that work in the high noise areas and you'll get them to wear a dosimeter to measure integrated noise dose. And then you can build your list of employees that are at risk of overexposure to noise. And then you can include them in your noise and hearing conservation program, which would include fit testing them and getting them to wear protective plugs. And so that's really the takeaway, is that you got to kind of go back and revisit your noise monitoring process so that you can revisit who should be involved in your noise and hearing conservation program and add to that program the requirement for fit testing. And that, in a nutshell, is what the government is asking you to do. Now, how they'll enforce it and when they'll enforce it, that will happen over the next year. On April 1st, I don't think you're going to see OHS officers marching around demanding to see fit test records. But the legislation comes into effect at the end of March. And so the expectation is employers will be moving towards compliance in the short term, in the near term. And that's really what it's about. So here's some of the questions that people asked. Why is there this change? I mentioned that we're continuing to see ongoing hearing loss, and that's not good. And so the government is saying, we better do something. And so the two things they've done is they've lowered the threshold when action's required, and they've pushed up the requirement for fit testing, which will formalize the requirements for workers to get education and training on the use of hearing protectors. How does an employer determine if their workers are noise exposed? I think I've explained that. A combination of noise mapping and dosimetry can measure who's at risk. Training for competency. Yeah, people were asking, how do you become competent? We used to teach this 2-day course. I don't think the university still offers it, but I used to teach a 2-day course on noise and hearing conservation. In our company, we teach people to become competent. Our occupational hygienists are taught by me or another certified hygienist. And it's a combination of education, training, and experience. And as I mentioned earlier, we've worked with lots of employers to help them become competent so that they can be doing this work themselves in-house. And typically we just work with you. We show you how a sound level meter works. We teach you about calibration, teach you about interferences, how to use a dosimeter, how to make your selections of who should be tested, how to interpret the results, and how to build out your noise and hearing conservation program. And so you can become competent to do this so that on the annual basis, when you have to do repeat testing, you're in a position to do it. The equipment's all available. When will measurement devices that meet this new standards be available? The type 2 device and the requirement's not new. Type 2 equipment is generally available. There's a large number of manufacturers. I think I showed you pictures of the Quest equipment. Distances for taking, training for testers. I think I talked about all that. The CSA standard talks about how you do a noise assessment, and that's what the government says. How do you get a good seal with earmuffs over safety glasses? The answer is you don't. If you wear safety glasses underneath your muffs, you're reducing the attenuation, and that A-rated or B-rated device will not perform as such. And so there are ways to get integrated equipment. But the short answer is if you have the glasses arms breaking the seal of the muff around your ear, you're not going to get its rated performance. Lots of questions about fit testing. Where can you get the equipment? How do you become certified? We've done a lot of fit testing. We've used the VeriPro system. Levitt Safety is a distributor if you want to buy the equipment. I don't know if they do any training, but we could certainly help you. We could come and do some fit testing at your workplace. We can show you how to do it. You can either rent the equipment or buy it. Probably rental makes the most sense to fit test everyone and then just do it on an annual basis. No big changes in audiometric testing. There's no real changes there at all. So whatever you were doing, you can continue to do. The only difference is the group of employees that should be included in your noise and hearing conservation program may be greater. And harmonization of legislation in Canada, you can blame Sir Johnny MacDonald for that when they signed the Charlottetown Accord, or not the Charlottetown Accord. The founding fathers gave occupational health and safety, education, and healthcare, and many other responsibilities to the provinces. So I don't think you'll get perfect harmonization anytime soon. So we're going to live in this federation model with different health and safety legislation everywhere. This idea of a rattling sound of a vehicle, I mentioned that at the beginning, that may not represent a noise-induced health risk, but it may be irritating. So that's not anticipated by the code, although there may be other reasons why you do want to deal with it. And the last question was other OHS changes. For sure, I can't speak to them all in this short webinar, but there's some changes to first aid, energy isolation, and some others. If there's interest, we could run a webinar on those changes and make it a little easier for people to understand. And so I've seen lots of questions flying in. Let's have a look here. So one question is, can a CRSP supervise an OHS student to perform noise mapping? I mean, if the CRSP is competent, if the CRSP knows how to noise map and undertake noise dosimetry and interpretation, I'm sure that would work. Yes, a question around the purpose of fit testing. The fit testing is, as this question says, is exactly that. It is a opportunity when the worker is sitting down with someone and they verify that they can wear their hearing protection properly, and they demonstrate to the worker that when they wear it properly, that they're getting good attenuation. What it does, it's forced sit-down education. Because the truth is, workers are not trained on how to wear plugs. They're just sitting there by the wall and it's expectation that they figure it out. And many workers don't wear them properly and they don't really know that they're not wearing them properly.
Glyn,
yeah.
Just to interrupt quickly, Katrina's emailed you all the questions gathered throughout the chat. And I'm just going to take this moment to make sure that everybody knows that when we hit 2 o'clock, please feel free if you need to leave. But we will continue the conversations and some of the other questions. There was quite a few. And then we'll also be enabling your mics soon and shortly. So that way, if you have other questions and as part of the discussion, just make sure you raise your hand and then unmute yourself as we direct you. Katrina's also putting into the link into the chat here a link for to allow us to get feedback, a little survey that would be greatly helpful. Just a 7-question selection there. So I'll just hand it back to you, Glyn. But again, if you need to leave, I saw a few people that were saying they had to go here quickly. So I just wanted to make sure, please go ahead. This is being recorded. We'll continue to record through the question period because others wanted to get all the questions later. So that way you can review this piece. Thanks again.
All right, thanks, Jess. Yeah, so one of the questions is, do I think hearing loss is due to the use of headphones and various types of devices listening to music loud? And certainly there's studies that do show that. The problem is that if your employee works in an area that's high noise and they suffer hearing loss and they can show they were exposed based on their previous employment, WCB will accept it as a claim. Medications can, the question is, can medications affect hearing? And yes, they certainly can. The question is whether this requirement defaults to prime contractors on large work sites. The prime contractor is responsible for health and safety of all people on site, and they are responsible for ensuring compliance. And so a prime contractor ought to make it a requirement of their contractors that they have met the legislation, including this piece. So prime contractor legislation does not change here. Prime contractors are responsible for all the employees and compliance on the site. Is it best to buy or rent a type 2 dosimeter? The question is how much noise monitoring you're going to do. If you're just doing, if you have fixed facilities and you want to do it once, it's probably better to rent it. We have noise equipment because we do noise monitoring all the time. If you're a big oil and gas company, and you're going to have a lot of facilities, it may be more cost effective. How much does a quantitative system cost? I don't know how much a 3M system costs. I know the VeraPro is like sort of $5,000 or $6,000. I'm not sure about 3M because I've never really looked at it because it's very limited to their type of hearing protectors. Question is, if a group comes to a site and they haven't been fit tested, are they still allowed to enter using earplugs? I guess what I would say is if you've got a group of visitors and you make sure they wear their earplugs properly for that visit, you will probably be meeting the requirements of the legislation. The technicality suggests that they should be fit tested, but I wouldn't personally be doing that. What I would be doing is making sure they wear the hearing protection properly for that little visit. VeraPro cost, I said that. Does read the manufacturer's instructions meet qualitative fit testing? I don't think reading the instructions meet qualitative fit testing. I think if you follow the manufacturer's requirements and you teach your workers to insert their hearing protection properly, you will be meeting the requirements. A fit test form. Does EHSP have a fit test form they're willing to share with us? Well, a fit test form, yes, if somebody who asked that, Blair, if you want to send me an email, I can give you the type of fit test form we use. It's not much different than a respiratory protection fit test form. It just says who, what, why, when, where, what type of equipment, what type of test, and then the employee is acknowledging they've had this work done. But yes, send me an email, Blair. My email is on the screen. Requirement for fit testing, they're saying annual, and they're saying to revisit your whole program annually. It says it in the code. Where can you get workers fit tested? There's going to be a variety of companies doing fit testing. We've done a ton of it for various hearing protective devices. So Ray, if you want to send me an email, we can talk about doing fit testing for your employees. How do you train someone? So dosimeters, sound level meters have a built-in, like have a calibrator that comes with the equipment. So a sound level meter is field calibrated, or it's like bump tested, it's verified. And then beyond that, equipment has to go back to the manufacturer for recalibration. So that's one of the costs of owning your own noise measuring equipment, is that in addition to the bump test that you do every time you use it, it has to go back for factory calibration. So that's expensive and it's a pain in the butt. Larry asked, 3M the only one has testing equipment? No, there's two major types, the 3M system and VeraPro. 3M is used for fit testing 3M hearing protective devices, and VeraPro is more generically available for all manufacturers. And then someone asked, can a CRSP supervise an OHS student to perform noise mapping and dosimetry? If the CRSP is already competent, then for sure the CRSP can train and educate a student and have them demonstrate their competency, and then they could continue to do the work. So competency is competency. It's defined in the legislation. It means education, training, and experience to be able to do the job they're supposed to be able to do. And so there's nothing more specific about it than that. And I don't know if that's all the questions or if any more questions came in here.
Hi, Glyn. We're enabling everyone's mics right now, that if you have a question you'd like to verbally speak, please just raise your hand and then we will just, and then unmute yourself. So it looks like, Neil, you have a question? Did you want to? Oh, hold on. Gosh.
Oh, I can answer a couple more questions that Katrina sent to me. Can I clarify the purpose of hearing protection fit testing? Is it essentially training? Yes, if you do qualitative fit testing, that's effectively what it is that you are showing workers how to properly insert hearing protective devices. You're having them do it and you're verifying that they can do it, and you get them to do it a few times, and you have a process to document it. I was on a webinar with the government 2 weeks ago about this issue. And the government still says that quantitative fit testing, like with the VeriPro system or 3M, is the gold standard for fit testing. So what that means exactly, whether they will be enforcing the gold standard on some companies and allowing for qualitative fit testing of others, I can't really say. But currently, both qualitative and quantitative fit testing is what the code says. Ray's asking what companies are from fit testing. I don't know who offers it. I mean, we do fit testing. Levitt sell the fit test equipment. I don't know who else is doing it in Alberta. We did it started about 10 years ago, and I thought it was a really good system. Employers were reluctant to include it because it wasn't regulated, but now it is. And Marvin asks, how about impact noise for those occupations that have firearms? Well, impact noise can cause noise-induced hearing loss as well. And I can't exactly explain WCB's process for admitting or rejecting claims, but I'm sure they ask other questions around things such as firearms use. And I'm sure the pattern of hearing loss from firearms use is maybe different than from noise-induced hearing loss. But again, that's outside my area of expertise. I can't answer it. Fit testing is required every 2 years or changes.
Oh, Glyn, and then next after this answer, do you want to? Oh, Janine had her hand up.
Go ahead.
Go ahead, Janine.
I'm just wondering, I'm taking a bunch of notes about noise measurements and where we should start in areas and noise mapping. I'm wondering if that would be the recommended process, or if you would recommend different process if we're doing noise assessments in a school environment.
Well, I think you start by creating a priority list. So certainly your shops, mechanical areas, maintenance areas. And I would start with just basic sound level meter and get sort of the background kind of noise. Just look for the peaks. And if you're getting peaks above 82, then you need to look at doing something else. But yeah, for sure, that's really what you start with is you just think it through. Where do we think the high noise areas are? And then we start to do some monitoring just with a basic sound level meter, just a direct reading instrument, to get a sense of how high are the levels. And as you do more and more monitoring, you'll start to get a really good feel for how loud 82 is. And I think it'll help guide you in your further assessment.
Thank you.
Someone asked what you do if a worker doesn't get a positive fit. I have to say, in my experience, I have not had experience where a worker can't get a positive fit, even with basic plugs. So unless something rather unusual, because some manufacturers even sell hearing protective devices, earplugs that are small, medium, and large, to address the fact that people's ear canals have different sizes. And so if you put in a plug and it hurts, you go to the smaller one. If you put in the plug and you can't get attenuation, then you go to the larger one. Other
Christy,
questions?
if you would like to go ahead and unmute yourself here.
Thank you. So my question is, we work in an environment, so heavy equipment operation, and so that's going to be different everywhere on every site, and we may have one shop. However, so when we have a company like yours that provides all of the testing and everything, if companies are going to maybe choose to go through a company to get this testing done and to help us build the program, do you think that there's going to be an overwhelming amount of work? And is there enough companies to do all of this work? You know what I mean? If we're having a company help with the noise and the levels and the testing and everything, how is there enough companies to do all of that right now?
Oh, yeah, yeah. I would say that most companies have got a good handle on this already. So most big employers that have high noise areas, all they're going to do, it's going to trigger them to do their annual review. They'll do a bit more testing and they'll continue on the way they have. So most big employers with high noise, noise and air conservation is not new. So the legislation's not new. It's just a little tweak to it. And so the types of workplaces that I would say it impacts the most is those that are generally low noise, like that question about schools. Generally, you wouldn't think of a school as being a high noise area, but I think what you're going to find is they will have some high noise areas that require signage and hearing protection, whereas before they probably didn't realize it. So I don't think it's going to be an overwhelming task to help companies that this is new to, or even help companies that really just don't have the time to do this reassessment. Just wanted to answer a couple other questions. How accurate is an iPhone to generate a general idea? Dave, the issue with an iPhone is that it's a type 1 instrument. And so without knowing, there's a lot of electric, like big motors and, heavy voltage and that kind of stuff. The electromagnetic fields associated with that, I'm told, I don't have actual direct experience, will skew the data. So I don't really have an answer for you. You can go play with your iPhone and see what it tells you. But the legislation says you're supposed to use the type 2 device. So it's kind of hard to answer your question exactly.
Pascal, are you still there? Pascal, you had your hand raised there for a bit. I don't know if we've lost him.
I just wanted to confirm the requirements for fit testing will be done annually, correct?
That's what the code says. It says you're supposed to do an annual review of your program, which in theory means you would do some follow-up monitoring to show that levels are the same. You would reinforce in terms of education and training, whether you do it at a toolbox talk or how you do it with your employees. But yeah, it would require an annual review.
But the review would not necessarily include a new noise survey if the environment doesn't change, correct?
Yeah, I guess if there's no changes, there would be no need to redo testing.
So for record retention and audit purposes, the employer will need to be able to demonstrate that fit testing was done annually for the workers that are exposed to 82 decibels and over.
Oh, no, 82 is the threshold for test noise measurement.
So 85
remains the threshold for when employees are included in noise and hearing conservation program. And just to answer another question that I saw there, 85 is twice as much noise as 82. Someone asked that question. Yeah.
Okay, thank you very much.
Yeah, part of your question too is that we can't answer is how will OHS enforce it? So we have lots of written legislation, and then we have the way legislation is actually enforced. And so what I'm trying to speak to today is what has been written, and then we'll see going forward how legislation is enforced. Someone asked about custom molded earplugs. Custom molded earplugs are fine and work, and they provide good attenuation. If they are deemed more comfortable by your employees and therefore you have higher compliance of use, maybe that's a way to go. I've personally never worn custom molded earplugs because I find the disposable ones easy to use. The issue with custom molded ones is now you have to make sure your workers are keeping them clean because they're going deep into your ear. And in lots of workplaces that are very dirty, it now requires a higher level of personal hygiene compared to disposables. So there's pros and cons. And I don't advocate either way. I think you need to think through what the needs are and the conditions of your workplace and what makes the most sense for your employees.
We've got 4 questions left here in the box. We've got Jesse, Eric, Tran, and then we will finish with Rick.
Okay, well, Eric
Carlson.
asks if worker uses muffs instead of plugs, how useful will the plug assessment be? If a worker is wearing muffs and they are class rated and they're being worn the way they're supposed to, then there's no fit testing required. So if you're using muffs and you're not having safety glasses break the seal, then it's class rated and you're protected. There's no fit testing of muffs. I answered that question. If employer provides workers with hearing protection, are they also required to provide audiometric testing? No, audiometric testing is required if a worker is at risk of overexposure. So if a worker is at risk of overexposure to 85 decibels of noise based on their job and task, then they're included in the noise and hearing conservation program, which means they need to have hearing protective devices and they need to be part of the audiometric testing. Your provision of hearing protection doesn't trigger them to have audiometric testing. It's the noise levels in their workplace. So if they're working in an area where they may reasonably be exposed to an average noise level of 85 decibels or more, then they need to be part of your hearing conservation program and they need to participate in audiometric testing. I think that I missed one more question. Let's see here.
We've got Rick here with what is your feelings regarding custom plugs versus molds? I think you gave about a little bit on the custom plugs.
Yeah, custom molded plugs. Yeah, I just mentioned that there's pros and cons. If workers find them more comfortable to wear and it increases employee compliance, that's good. The challenge with them is they require a higher level of personal hygiene to keep them clean because you are pushing them deep into your ear. I mean, you still have to have clean hands before you insert disposable plugs too. So that's all part of the education process. So as I mentioned, I've never worn custom molded earplugs because I find the disposable is fine. But I also know that lots of companies have had good success with custom molded earplugs. So I'm not speaking in favor or against them. It's another option that you can use. Yes, and so we would look forward to any feedback you've got on the webinar, and if there's other topics you'd be interested in hearing about, we'd be happy to offer ongoing webinar series on anything related to occupational health and safety, industrial hygiene, norms, respiratory protection, whatever would be of interest to you. It's easy for us to do, and we're happy to help out. All right, well, thanks for participating, and as I think Katrina mentioned, we'll get a link to the recording and make it available so you can share this presentation with your family. That'd be a good Saturday afternoon activity to talk about noise and hearing conservation. Anyway, thanks for attending. We appreciate the interest, and we're here to help. If you've got further questions, you got my email there. Send me a note.
Thanks, Glyn.
Yeah, thank you to all of you. We'll see you later.
Thank you, everyone.
Bye.
Bye.